To start off any day, you have to play some music on the car ride to school. To calculate the wavelength of the radio station, I use the formula speed equals wavelength times frequency. All radio frequency is measured using hertz, and frequency measures how often something occurs. I know the frequency of the station is 106.1 times 10 to the 6th hertz, and the speed of all radio waves is 3 times 10 to the 8th centimeters per second. So when you input the values into the equation, you get a wavelength of approximately 2.8 centimeters for the radio station. This wavelength is a relatively low wavelength compared to the average radio wavelength of 3.4 centimeters. As I stop at the stop sign, my acceleration decreases due to the lack of force applied. Acceleration comes from the equation force equals mass times acceleration. As I begin to press the gas and go again, my acceleration will increase because of the relative increase in force. With the help from the gas pedal, my car is able to change its velocity at a faster rate than when I was stopped or using my brakes. As time increases, so will my acceleration due to my car's movement of an unconstant rate. The acceleration of my car can be calculated by velocity final minus velocity initial divided by time. Not only does my acceleration change with time, but the position of my car changes as well. This can be shown in a position versus time graph, acting if my car is moving at a constant rate and speed with no stops in between. As for the velocity versus time graph, my car would reflect a single straight line due to my constant speed over a designated amount of time. On my way to school, I encounter a cone in the middle of the road and collide with it. This collision is an elastic collision because my car and the cone do not stick after coming in contact with one another, but merely have a change in velocity. Although they are not repelled in different directions, this collision is still elastic due to the greater force of the car, unable to be strongly affected by the cone's force. After the collision, the two objects, my car and the cone, are equal to their total kinetic energy before the encounter. Since energy is neither created nor destroyed, braking to a stop in order to park my car converts kinetic energy to heat energy in the brakes through friction, demonstrating Newton's law of conservation of energy and the idea that the total amount of energy remains constant. Ultimately, energy may change form, like in this case from Ke to heat, but the total amount of energy will always remain the same.
When you are walking around campus to get to class, you usually walk with a constant velocity, as long as you're not running late. Velocity is the change in position over the change in time. A velocity is typically read as a certain number of meters covered per second. For example, if you walk 4 meters in 2 seconds, you walk at a velocity of 2 meters per second. Some people walk to class at a slower constant velocity, and some walk at a faster constant velocity. If you're sitting in class and then get up to go to the bathroom, you will have a positive velocity on the way to the bathroom, but a negative velocity coming back, as you are moving back in the direction toward your original starting point, the classroom. If you are walking up a flight of stairs on your way to class, your energy is converted into gravitational potential energy. Gravitational potential energy is a result of the gravitational field impacting the energy an object possesses. The formula for gravitational potential energy is mass times the acceleration due to gravity times height. The acceleration due to gravity is a constant of 9.8 meters per second squared. An average student of 60 kilograms that goes up one flight of stairs in the science quad would have 970.2 joules of gravitational potential energy. As you walk up the stairs, you are also doing work. Work is a measure of the amount of force someone applies multiplied by the displacement they cover. Work is measured in joules, as it measures energy. If you expend 50 newtons of force while walking 1.65 meters or up one flight of stairs in the science quad, you expend 82.5 joules. You are also generating power as you walk up the stairs. Power is the measure of work over a certain amount of time. Typically, power is measured in joules per second or watts. A task, like walking to class, can take the same amount of work for two people who are walking the same distance and require the same force to do so. But if one of them runs to class and the other walks, the one running generates more power. If both students do 82.5 joules of work, but one student runs to class in 10 seconds and the other walks to class in 30 seconds, the student running generates 8.25 watts, and the student walking generates 2.75 watts.
As you can see, good old Paige Franzak is standing at the top of the diving board at Los Gatos High School. And since she's standing up there, that means that she has gravitational potential energy. When an object is above Earth's surface, it has gravitational potential energy, or GPE. The amount of GPE on an object depends on its mass and its height above Earth's surface. To calculate Paige's GPE on Earth, you will first need to multiply the mass of the object, which is Paige, by the height of the diving board, which is about 2 meters, and then multiply by negative 9.8 newtons per kilogram, which is the gravitational force of Earth, to find the GPE. As Paige jumps off the diving board, she's applying force to the diving board. And because of Newton's third law, the diving board is applying equal but opposite force back onto Paige as she's applying it to the board. Newton's third law states that for every action, there is an equal yet opposite reaction. This statement means that in every interaction, there is a pair of forces acting on the two interacting objects. The size of the force on the first object equals the size of the force on the second object. The direction of the force on the first object is opposite to the direction of the force on the second object. Forces always come in pairs, equal and opposite action-reaction force pairs. So, as Paige adds force to the diving board, the board is also adding an equal and opposite force to Paige. After Paige jumps, her energy is transferred into kinetic energy. When an object falls, it transfers its gravitational potential energy into kinetic energy, which is the energy of motion. Kinetic energy can be found by multiplying half of the mass of Paige by the velocity that Paige is traveling, and that number will be squared. Kinetic energy can be set equal to GPE to find the velocity of Paige as well. However, as Paige jumps, her GPE is transferred to kinetic energy, but realistically, some of that energy may be lost due to Newton's second law, and it might be lost due to heat.